Hello and welcome back to grade 10 maths. Today we are estimating sets. Right, before we begin, let's just look at the quick definition of a set. A set is a value in a root, whether it's a square root, a cube root, or whatever the root that cannot be simplified further into whole numbers or integers. Sets are irrational numbers. Example of sets can include the square root of 2, the cube root of 4, the negative square root of 5, the square root of 7, the fourth root of 5, and etc. Why are these considered as sets? Is because if you look into your calculator and you punch the square root of 2, you'd see that you find 1,41421, etc. Right, so this is actually a non-terminating decimal, and it is also a non-recurring decimal. That's why the square root of 2 is considered a set. Right, in order for us to understand this topic, we also need to look at the concept of integers. Right, integers, these are simply whole numbers that extend to include negative numbers as well. So if you close just the side of the list, you'd find that from 0 going all the way to positive infinity, these are just whole numbers because they start from 0 and they move in intervals of 1 all the way to infinity. The moment you include negative numbers, these are whole numbers. Again, they move in steps of 1 all the way to negative infinity. This becomes integers. Right, so we need this information so that we can be able to answer questions in this topic. And the question may come as estimate a set, or it may come in a typical way to say between which integers, right, between which two integers does a set lie. For an example, let's consider the square root of 12. As the first example, let's look at the square root of 12. Between which two integers will the square root of 12 lie? Ladies and gentlemen, this is one easy topic. And for you to be able to understand this one, I will quickly focus you on the idea of perfect squares, perfect cubes, perfect whatever. Right. If we look at our perfect squares right here, I have a table that I've just compiled right now of squares and cubes. So it's perfect squares and perfect cubes together with their roots. So if we're talking about a square, we'll talk about its square root. So any number here, when I square the number, so if I take 1, I square 1, I get my 1 back. And similarly, if I take the square root of 1, I get my 1 back. Similarly, 5 squared, hence the square right here. 5 squared will give me a 25. And if I take the square root of 25, it will give me a 5. Why do I need this? Right. The reason is straight and forward. In order for you to be able to estimate a set, one easy way is to actually look at this set without its root. Look at the set without the root. So what do I mean by that? If we are going to look at the set without a root, we are going to take square root of 12. We'll look at it without the root. So we'll have 12 right here. And then we know that because the question says between which two integers, we know that one of the integers is going to be smaller than this 12, and then one of the integers is going to be greater than this 12. So it means the one that is smaller than 12, we'll write it on the left-hand side of this inequality, and then the one that is greater than 12, we'll write it on the right of this inequality. Right. So now the first way, the hint is we are looking at the square root. So it means you will go to a table, which you will also write for yourself, just in case you don't know your squares. So you will write your squares, and then you will check. These are all my squares right here. 1 up to 10 is normally sufficient. So if I'm looking at all these perfect squares right here, I'm going to look between which two numbers does this number without a set, without a root lie. Right, I'm looking at 12, so I'm going to look at two perfect squares. which I can find 12 lying in between. Right, so if I can check between 1 and 4, there's definitely no way I can find a 12 between 1 and 4. A 4 and a 9, definitely not. And then a 9 and a 16. So I know that 9 is less than 12, but 16 is greater than 12. So I expect my 12 to be somewhere here. So now I have identified between which two perfect squares my 12 will lie. And then I take those ones, and then having the smallest one on this side and then the biggest one on the side. And then I will have my 9 right here. I will have my 16 right here. Right, so now I have identified between which two perfect squares this lie. And then again, I'm going back to answer the question now. The question was looking at a square root. So what I will do now, I will introduce the square roots in all these three numbers. Having done that, I will have the square root of 9 right here. I will have the square root of 12 right here. And then lastly, I will have the square root of 16 over here. Right, and then I know that from my squares and their cubes and their square roots, this, if I have 9 and I take the square root of 9, it will give me a 3. And then the square root of 9 is simply a 3. And then the middle number, you'll just leave it as it is because it's your set. Remember, it cannot be simplified further. And then you will have your other perfect square, which is 16, and the square root of 16 is simply a 4. Right, and then I find that the square root of 16 is simply a 4. Therefore, to answer the question, between which two integers does a set lie? So which set are we talking about? 4. Right, so it means the square root of 12 rather, not a 4, pardon me. The square root of 12 lies between which two integers? It lies between 3 and 4. Right, let's quickly check that. We know that the square root of 12, when you punch it in your calculator, you get 2 root 3, but we are interested in the decimal part of the answer. So we find that it is 3.46, right? 3.46, we see that 3.46 is definitely greater than this 3, but it is definitely smaller than this one. So it's safe for us to say the square root of 12 actually lies between the integers 3 and 4. That's one example. Let's look at another one, this time around looking at a cube. The second example would be the cube root of 50. Let's look at the cube root of 50. Right, ladies and gentlemen, again, this does not change. If we have a cube, the mathematics still does not change. The hint lies on the cube right here. So it means if we are having a cube right here, it means we are no longer going to be looking at perfect squares, but now we are going to be looking at perfect cubes. Again, I've done the same thing right here. This time around, I have my x values, and then I have my x values cubed, and then I have my cube root introduced right here. Similarly, 1 cubed will give me a 1, and then the cube root of 1 will give me a 1. Similarly, 3, if I take 3, I raise it to a power of 3, I get a 27. So it means 3 cubed is a 27, and then the cube root of 27 gives me back my 3. So all these answers or these values, I found them exactly the same way I've explained for the squares. So same technique, but now for the cubes. So it means number 1, we bring it down without the root. So if we bring it down without the root, we'll have 50. Again, I know because I'm estimating two integers, I know there's going to be an integer greater than this and an integer smaller than this one. So again, I'm going to go back now to the cubes. I'm looking for two numbers between 50, between which 50 lies. Those two numbers must be perfect cubes. Right, so these are my perfect cubes. And then I'm looking at this one. Is it between 1 and 8? Definitely not. 8 and 27? Definitely not. 27 and 64? Yes, I'm looking for 50. So 50 should be between 27 and 64. Right, we go back. The smallest one is 27. Then the greatest one is a 64. Right. Then again, now what I'm going to bring back, I'm going to bring back a cube. I'm going to cube root the side, bring a cube root the side, and bring a cube root the side. Again, you go back. If you still don't understand it, the cube root of 27 is simply a 3. I'll have my 3. And then the cube root of 64 is a, pardon me, you still have your cube root of 50 here. And then lastly, the cube root of 64, you'd find that it is a 4. Therefore, what does this mean? It means that the cube root of 50, this will lie between integers 3 and 4. Right, it would seem like every answer that I'm getting is between 3 and 4. This is just coincidental. It's not always the case. Please bear that in mind. Quick check again. We'll have the cube root of 50. Then we find it is 3.6. 3.6 again is greater than 3 but less than a 4, which makes it correct. Let's look at one last problem, this time around now with a negative. So suppose we are given a question, estimate the set or between which two integers does the negative square root of 28 lie. Right, the moment you introduce a negative, grade 10 start getting scared, and it should not be the case. What you need to do here, work with the square root without the negative. But bear in mind that you are going to have your negative substituted back at the end just by multiplying. So what you would do, work with the root without the negative. So again, we'll go back to bringing down 28 without the root, and then we bring it down without the root, without the negative here and without the root. So again, estimating between which two integers, we are looking at squares now. We go back to the table of squares. For squares, we are looking at 28. 28 is supposed to be between 16 and 25. I mean, between 25 and 36, because 28 is greater than 35 but less than 36. So it's between 25 and 36, which are our perfect squares. So we'll have 25 the side, and then we'll have our 36 the side. Again, what you need to do, bring back the square now. Bring back the square root, bring back the square root. Then the square root of 25 is simply a 5. And then the square root of 28, you just leave it with your root. Then the square root of 36 is simply a 6. But bear in mind that we used this without a negative. Now we need to multiply by the negative. Multiply by the negative 1 that we removed. Right, and then we are going to take negative 5 multiplied by 1. We still have the inequality. This one also multiplied by negative 1. Negative 5 times negative 1. You still have your inequality, which is root 28 multiplied by negative 1. And then you have 6 multiplied by negative 1. Remember, it's mathematics. You do the same thing throughout. If you have your 5 times negative 1, you'll have your negative 5. Now, whenever you multiply or you divide by a negative number, the inequality sign will always change its direction. Then from less than, it becomes greater than. And then you'll have 28 times negative 1 is going to be the negative square root of 28. Then again, similarly with this one, because you are multiplying with a negative, the inequality sign will also change direction. We'll have negative 6. Therefore, what does this mean? It means that negative square root of 28 will lie between, remember you start with the smallest integer, and our smallest integer in this case is negative 6, and the other one would be negative 5. Right, quick check. you'll have negative the square root of 28. You'd find that it is negative 2 the square root of 7, which is negative 5.29. Negative 5.29 is between negative 6 and negative 5. That is definitely true. Right, so this is how you tackle estimating sets. Let's look at a typical example or typical exam question that can come, where you can find in a particular exam question paper. Right, the question might come as follows. The question might come as follows, right? Given P, and your P is given as the square root of B squared plus 4AC. The first question, determine the value of P if A is 2, B is 6, and C is 2. Leave your answer in simplest set form, right? So it means we need to leave it as a set. Right, so I'll just copy down the question quickly. We are given that P is the square root of B squared plus 4AC. First question, 4.2.1. If A is 2, B is 6, and C is 2, what is P? Right, so this is just a matter of substitution, a question of substitution. Therefore, it means that P is going to simply be the square root of. Right, I always emphasize to say whenever you make a substitution, use brackets. Right, our B is a 6, so I'll have a 6. This 6 carries a squared, so it's 6 squared plus 4. What is my A? My A is a 2. And then what is my C? My C is also a 2. Right. Then when I substitute this quickly, I'll go punch it in the calculator, but you don't have to, but you can still punch it in the calculator, and you would find that you'll have 6 squared. So I'll do it without the root, so that at least I have a nice answer. 6 squared plus 4 into 2, and then times another 2. Then I get 52. So it means this number under the square root will be 52. And then from the number of perfect squares, the list of perfect squares that I dealt with, I can already see that 52 is not a perfect square. So definitely 52 is an irrational number. Right, 4.2.2. The second question would be, state whether P is rational or irrational. I just mentioned right now to say the square root of 52, because if you can check the square root of 52, you get 2 root 13, which is 7.211 with an non-terminating and non-recurring decimal, so it makes it irrational. Therefore, it means P is irrational. Right, your irrational is simply a Q with that prime on top. Or you can just say P is irrational. Then the last question, 4.2.3. Between which two consecutive integers does P lie? Right, so it's a question that we've just done right now. Estimating the set, we have the set 52. Right, to estimate it again, remember, write it without the root. And writing it without the root, you will have 52. We know we have two integers. And then again, we're looking at squares. Right, for squares, 52. The square root of 52 should be between which two integers? Right, quickly, let me just get my table again. All right, my table says that I'm looking for 52, and 52, I see 52 is greater than 49 but less than 64, so it's between 49 and 64. So I'll have my 49 this side, I'll have my 64 this side, Then introduction of square root throughout. I will have the square root of 49 being a 7 less than the square root of 52 less than the square root of, the square root of 64 being simply an 8. Therefore, to answer the question, the square root of 52, which in this case is p, it lies between 7 and 8. And you will realize that these integers definitely are consecutive. Consecutive meaning that they follow each other. So you would see that 7 and 8 are consecutive integers. Therefore, the square root of 52 will lie between 7 and 8. Ladies and gentlemen, this wraps up this topic. We will see you again in the next one. Please, if you have any questions or there's something unclear in the presentation, feel free to just post it on the comment, and then I will definitely follow it up with you. If that's all, then all I can wish for you is all the best. Let's enjoy the mathematics because it's simple and it's fun. Thank you very much for watching. Till we see each other again. Bye bye.